Hello, and welcome to 5 Minute Math. Today we are looking at activities that we can use to teach the Algebra 1 standard A.6A. This is a blog on my website, 5minutemath.net, and I will put the link to this particular post in the video description. So we are looking at TEKS A.6A, determining the domain and range of quadratic functions and representing that using inequalities. So we start off this blog post with some teaching videos here showing how to find the domain and range from graphs, from tables, and from equations, just so everyone is caught up on how that works. The reason we're doing this is because of STAR. On the 2023 STAR test, this particular item, number 11, only had 47% correct here, and we simply had to identify it. Now, the trick here is that it's not in vertex form. This is in standard form. So students had to be able to identify the vertex and use that to find the range. And so how we solve that is displayed here. And then we had a table of values, and that's not much different, right? That's actually a little bit worse, 44%. But you notice we have a whole lot of items there that are going to be in fractional form, improper fractions, proper fractions. That just makes it a little bit more difficult, and how we solve that is right there. So the theory behind all of these activities that I'm going to share with you, 5 of them, is called active playful learning. In short, students need to have fun, they need to be active and engaged, they need to have meaningful tasks, it needs to be social, joyful, and iterative, and if all of that happens, math is fun, and students learn a lot more. So this particular video that I'm making right now will go right here underneath this sentence. Here's a walkthrough of all the activities on this blog post. Our first activity is called Talk a Mile a Minute. Now, if you've seen my other video and my other blog post about the domain and range of linear functions, it's the same activity because domain and range of linear functions is going to be similar, not identical, but similar to the domain and range of linear functions and quadratic functions. They're close. So what we do here is we pair students together. We display a term we do as the teacher related to A.6A, so domain, range, x-axis, y-axis, x value, y value, axis of symmetry. Display something. Partner A has 1 minute to name as many phrases as they can related to that term. Partner B simply listens and writes them down. Then we show another term and they switch. Partner B names as many terms as possible. Partner A listens, writes them down. What they do next is they have 3 minutes, and what they do is they try to circle one term from each list, the first and the second item that were shown, that they think will be on somebody else's list, the most common term they can think of. And then they also circle one term that they think is uncommon, will not be on anybody else's list, because you got everybody in the class doing this in partners. Then as a class, you go over the circle terms, and pairs earn 1 point for each term that they correctly guess will be on another list for the common terms. And then if they correctly identify an uncommon term, a term that they only have on their list, and then nobody else does, even if it's circled or uncircled, they get another point. So it's possibility of 4 points max. 2 common terms, 2 uncommon terms. Really, what you're doing is you're just talking vocabulary, and you're listening to how they relate that vocabulary to this particular standard, to items in the world, other concepts, previously learned ideas, and ask them, because after they play this a few times, they'll come up with the most obscure and random connection. Have them justify it. The class can decide whether or not that actually does relate. So if you're talking x-axis and they say, Oscar the Grouch, that's probably not going to be a related term unless they can come up with some really strong justification for that. So, what are some variations? You can provide a list of closely related terms to ban. So you can give them really close synonyms or related terms and say you can't use these. So you want them to, spread their net a little bit wider. You can create a list of bonus words that earn an extra point if they do appear on student lists, whether or not they're circled. So that could be almost that same list, but you just don't show that to them. And you say, hey, there's some bonus points for some closely connected terms. You can have pairs work on different words simultaneously, rotating several terms until they've gone through all of the terms together. This helps if you've got students that aren't really listening to their partner, they're listening to the pair next to them. You can have them working on different words, but you'll need, 4 sets of words or 6 sets of words, something like that. And then you can allow students to select maybe 2 words that will be on the other list, 2 common words. That's just going to reinforce those common terms. It's a lot of fun, it's a lot of talking, and you hear a lot of associations and connections between domain and range and just random things. Our second activity here is called quadratic sliders. So we're using some type of online tool, most likely Desmos, but you might have something else you like. You're going to open it up, and they are going to enter in the vertex form right here. So y equals, and you see it right here. And then as you enter this in, you're going to have that option that says add slider. So you want to add slider for all, for the A, the H, and the K. So here's a picture of what you're wanting is these sliders. And what we're wanting to do here is we are wanting to give them clues, right? To say, and really what we're doing is we're not really messing with this A quite yet. If we're wanting to move the vertex into, for example, quadrant 3, I'm just going to manipulate the H and the K. I'm going to manipulate those values so I can move the vertex over into whatever quadrant I'm wanting. Now, if you want the A value to change, then you're going to need to just basically let them know you want the function to open upward or downward, and you want it to be very wide or very narrow, and then we're going to manipulate the A here. And then what you do is after you have students meet the clues, not everyone's going to be exactly the same, but you can have students share some of their values, and you can discuss the similarities, right? So if I wanted to move them over into quadrant 3, I would need some specific values for H and K. And if I wanted it to be downward and be very wide, it would be negative, but it would not be a very large negative number. It'd be a small negative number. Now, what are some variations? You can actually add some restrictions. This is kind of interesting, and you can add them as curly braces here. And you can add L and R as sliders. So here's an example. You can actually have these curly braces, X and Y, and then what this does is you're actually just adding sliders for this L and the R, and it goes right here, and you're actually restricting the domain and restricting the range so you can get uh, really, really tight representations of some of these quadratic functions. You can allow students to lead the activity, so they give the directions, they tell the students where to put the vertex quadrant 1, 2, 3, or 4, and how it opens. And then what you can also do is you can have their students take these values, right? You don't want them just to spend so much time with the sliders, they can't actually put this into an equation form, right? So take their A, H, and K values and actually write them down into an equation written in vertex form that represents whatever function they describe. So make sure they can at least take this function with the sliders and write it all out. And then what you could do is you can show a graphed function on Desmos, and there's an option to hide the sliders. Have them work together to approximate the values of H, A, K, H, and L, and R based on the graph, then reveal it to them. So there can be a little bit of guessing there as they're trying to find where's the vertex, what are the values of the L and the R, and then show them to them. And that's a lot of high level thinking right there. Our next activity is called Axis of Symmetry Match. Students are simply using this time to practice, and this really comes from, let me scroll back up here, this particular problem right here. One of the ways that students could solve this problem is they could find the axis of symmetry, right? That's the b over negative 2a, and then plug that y value in, or that x value in, to find the y value, and that is going to be your vertex. So students, that's one way to solve this, right? You could also, complete the square if you want to do that. But we want to show students that you could use the axis of symmetry, find the vertex, and if you find the vertex, you can identify the range. So what we're doing here is we're giving them basically some axis of symmetry match cards, and I've got example right here. So you see we've got 4 columns, and these 2 columns, just for your own purposes, go together. right? So the axis of symmetry for this is x equals 0. The axis of symmetry for this one is x equals -1. Axis of symmetry for this one, x equals -2, and so on. And so you've got 10 different sets there that you can cut out, and you want to mix them up. And then what you're wanting them to do here is you are, without calculator, pencil, or paper, you're wanting them to match the standard form with the corresponding axis of symmetry. And then you can allow, and then once they have those 10 matches, you can allow them to check their matches with another pair. And this helps with mental math. This gives them the ability to really quickly get that b over -2a as your axis of symmetry. And all we're doing is identifying the axis of symmetry, knowing that is a key first step in identifying the vertex of a quadratic function. Now, variations. Maybe we do want them to use pencil or paper. It might be a little bit too much to do mentally, so we can let them use a pencil or paper or a calculator. And then after matching all the cards, have students take 2 pairs, not all, find the vertex by substituting that x value into the equation to find the y value. And then when that's complete, they need to note the sign for A, whether it's positive or negative, and then write the range. You can allow students to do this individually, right, and use this as a memory match game. The original design of this is not that all of them are facing up. It's not necessarily a memory match, but it easily could do that. And then have them graph functions on the graphing calculator to check to see if they've correctly identified the axis of symmetry. Take 1 or 2, plug it into their calculator, into Desmos, and make sure they've correctly identified that axis of symmetry. This next activity, race to the inequality, is also from that A.2A that identified the domain and range of linear functions blog post. And you're wanting them to work collaboratively to describe the range of quadratic equations with inequalities. So you want some volunteers. You want 9 volunteers to represent the digits 1 through 9, printed up or on whiteboards. And then you want 4 volunteers to represent y, a negative sign if needed, and the inequality symbols greater than or equal to and less than or equal to. And then you want the rest of the class to be split into 2 teams. You're going to display the graph of a quadratic equation, just any graph. So I would just open it up on Desmos, type something in, display that graph. And then those volunteers should be facing the class with their backs to the board, so they're not necessarily seeing what is on the screen. And the first team's task is to represent that range. They need to arrange those volunteers in a way so that they will represent the range. So y is greater than or equal to, or y is less than or equal to. Then they need to use one of the digits and possibly use that negative sign. Then you reset the volunteers, and then that second team works on a different quadratic equation. They're just trying to beat the time of the first team. So you're just trying to race together to see how quickly they can arrange the volunteers that cannot look and arrange themselves into a correct representation of that range. So one variation is don't show the graph. Show the equation in vertex form and have them identify the range of the function that way. Another option is to use alternative scoring. So rather than just basic time, say, hey, you get 5 points if you solve it in 20 seconds or less, 4 points if 30 seconds or less, so on and so forth. If you want, you can have students arrange the volunteers into both domain and the range. For that to, be useful there, you would need a volunteer representing x, and most likely an infinity and a negative infinity. And then possibly you could have range limitations that require 2 digits like 21, and you might need to add an extra volunteer to represent 0 if you're going to do 10, 20, 30, or so on, and then just make sure that each digit is not used more than once. And then finally, we are looking at an activity called table range. So they're going to identify the range of quadratic function given a table of values, and you should recognize this problem. This was on the 2023 STAR test all the way back up here. It's this one, number 32. So what we're doing here is you want to give students 2 half sheets of paper, give each team, and they're going to be teams of 4, one that's got the y is greater than or equal to, and then one with y is less than or equal to right there. and you want to display a table of values. So for example, you could do this particular one, which is right there, and you would just display the table of values, not necessarily the entire problem. And then you want to give them a small time limit, like 20 seconds, to where they converse with each other. They identify the range simply looking at the table of values. And then when the time is up, each team sends a representative up to the board and they place either the y is greater than or equal to or the y is less than or equal to sheet of paper on the dependent variable value that represents the limit of that range, right? So for this one right here, what you would want them to display is you would want them to say y is going to be, and then they would include this less than or equal to, and they would put it on that 19/4, because that 19/4 is like 4 and 3/4, and that's going to represent the top of the parabola here, and the rest of it kind of goes down here on these y values. So the correct answer for this particular one would be to put this one right here on this 19/4. So ask students how, and this is where you really want to probe their thinking. How did you know that was going to be the top of the parabola? How did you know that it opened downward? So you needed that less than or equal to rather than a greater than or equal to. This is where you really get to stamp their learning. So it doesn't necessarily have to be a race. You just want to see what each team does. But variations could be you can replace the half sheets that have the y is greater than or equal to, y is less than or equal to, then you can have them replaced with all real numbers greater than or equal to and all real numbers less than or equal to, because that's actually how it's represented here in this particular problem. They didn't use the symbols, they used the words. You can have a coordinate grid on the board after identifying the range. Ask another team to come up, plot the points, and sketch a graph. Right, so let's actually graph this to see whether that is the limit of the range, that 19/4. You can use a mixture of decimals, mixed numbers, and proper fractions for the dependent variable values in the tables. That's what made this one so difficult, is these improper fractions. You've got a few integers there, but these three improper fractions made it just a little bit harder for students. And then you can also change up the directionality of the tables. This one happens to read horizontally, but you can have some read vertically as well. And those are some different ideas that we can use to teach the Algebra 1 Standard A.6A.